Recapping September 21st imaging lab on the abdomen. So in this lab, we mostly focused on the gastrointestinal tract and its spatial relationship between the individual pieces and how we can interpret them on radiograph and CT scan. So let's start with the radiograph side of things. How do we recognize if a part of the gastrointestinal tract is normal or not? So the large intestine is much more subjective than the stomach or the small intestine, which have set ground rules for interpreting their health. The large intestine is usually what you want to do is, first of all, you know where the major parts of the colon should be. The ascending colon should be on the right side, the descending colon should be on the left side, and goes to the middle down towards the anus through the pelvic inlet, and then the transverse colon should be caudal to the stomach and run across from left to right. So if something's not in the right spot, that's a cause for concern potentially, and if something is significantly larger than another part of the same colon, that's another sign for a cause for concern. On the other hand, stomach and small intestine, they actually gave us measurable margins for judging whether it's healthy or not. So the stomach, first of all, should always be a left-sided organ, so it sits under the left rib cage. And if it's extending beyond that rib cage, there's probably an issue. It should most of it should sit under the rib cage. Furthermore, it should be at most about 3 intercostal spaces wide when you're looking at it from a lateral view. So if it goes like that, you know you have a problem. You should also be able to recognize the fundus and the pylorus normally on a regular radiograph, although they might become even more present when you have a problem. So if we look at our stomach relative to this radiograph, we know that the esophagus is pointing cranially, and that the duodenum should be pointing caudally. So the way it kind of works is the esophagus is pointing this way, duodenum is pointing this way, and what we see is that on a left-sided view, the pylorus is going to be closer to us, and on a right-sided view, the fundus will be closer to us, because now we're this way. And so the point to take away from this is we can tell the shape of our fundus and our pylorus based on gas and fluid opacities depending on which side we're laying on. So if the pyloric part of the stomach is a more right-sided organ, if you were to lay on your left side, then the gas would float upwards towards the right side, towards the pylorus. So the pyloric part, as I wrote here, the red represents gas opacity. You should see on a left lateral view the pylorus being filled with gas. And then you might see some fluid opacity up more dorsally. On the other side, if you are on a right lateral, now you're laying on the side where the pyloric part is, so the gas is going to flow to the left, flow to the left and go towards the fundus of the stomach. And so the fundus is a more dorsally oriented part of the stomach, and so you'll see it more dorsally and maybe a fluid opacity where the pyloric part should be over here. Beyond that, we also talked about granular material. Unless a dog is recently eaten, you should only see granular material in either the stomach or the large intestines. You should never see granular material in a normal small intestine unless the dog has just recently eaten. And granular material kind of looks like sand, like little specks of more hyperopaque or more opaque material surrounded by a darker or less opaque lucency beyond that. Now, normal small intestine, we have a lot more rules that we can use to judge if something's healthy or not. First of all, when something is traveling through the small intestine, we should see peristaltic motion, and that is represented as the analogy of a string of pearls. And basically, as you travel down that small intestine, you should see little blebs going out of that small intestine like so, and they should be what we call concentric. They are centrally located. You shouldn't see a divot out of the small intestine like that, where it's not equal on both sides. And what that is, it's just muscles contracting peristaltically, or doing peristalsis, so we're kind of like just forcing things down the tube. That's a normal appearance for something traveling down the intestine. Now, the references we use to say this small intestine is not healthy are, first of all, it shouldn't be larger than a large intestine. Then, also, it shouldn't be 2 times the width of a rib. It should be less than the space of a single intercostal space. You shouldn't be, they gave a more general thing of saying, if you take one segment of small intestine and compare it to another segment of small intestine, one segment shouldn't be more than 50% larger than the other. And that seems like a kind of subjective number though, so it's kind of hard to make a reference to that. I think the intercostal space and the 2 times the width of a rib are better margins. Also, they said it shouldn't be larger than the central body of lumbar vertebrae too. That's another one where unless you have a ruler, I feel like it's hard to judge that one. All right, and so that's the general way of telling health of things on radiographs. Now, we also looked at CT scans to get a sense of how things are related to each other in a more transverse aspect. And so let's start with the more cranial of these 2 cross sections that I've drawn. This one. This one is at the level of the 12th thoracic vertebrae. So we're still going to see some what is called rib on the more internal aspect relative to muscle. So to orient ourselves, we're going to see at this level a lot of liver. And so all these purple blobs over here are lobes of the liver who we'll probably learn about later on. So I'm not going to really say who's lateral, who's medial, so on and so forth. And they're going to extend from the right side of the body, and they're going to kind of wrap around medially towards the ventral aspect and even extend a little bit around the stomach. We know that the liver is the most cranial organ, so as you're moving caudally through the CT scan and past your diaphragm, the first thing you should see is your liver. Now, I've drawn in some muscles. Let's talk about those next. So, as usual, our muscles that are lateral and dorsal to our vertebrae are going to be our axial muscles. And then ventral to the vertebrae, at this level, we can still see some of the musculature of the diaphragm, the left and right cruce. Right cruce extends a little bit more ventrally than the left cruce. On the more lateral side of the walls, we're going to see, since we're still in the land of the thorax, we're still going to see some latissimus dorsi, and so that's this muscle up here. As we move a little more ventrally, we're going to have our external abdominal oblique, and the muscle that runs in between our ribs are our intercostal muscles, so external and internal intercostals. At the very midline of our body, we're going to see our abdominal rectus. Remember, we're still caudal to the xiphoid process. The ribs kind of extend a bit further caudally than the xiphoid process does. So it's okay that we don't see any sternum here, but we still see the rectus abdominis, which we know attaches to the xiphoid process. The falciform ligament is going to be sticking right down the center of our body, and that's going to connect the diaphragm and the umbilicus, as well as have attachments to the liver. So this orange bit is attached to the liver from the ventral body wall, and it's our falciform ligament. And these 2 muscles are going to be our rectus abdominis, like I said before. Now, looking more internally, we should see just ventral to the vertebrae, our aorta. And notice it is dorsal to the left and right cruce of the diaphragm still. We also have 2 veins that are worth pointing out. More dorsal of the 2, kind of within a lobe of the liver, is our caudal vena cava. And then more ventral to that is going to be the hepatic portal vein. The caudal vena cava, we know, brings deoxygenated blood back to the heart, and I assume the hepatic portal vein is associated with the liver to bring hepatic circulated blood back to the heart as well. I don't know if it meets up with the vena cava. I didn't check on the CT scan. I digress. We'll learn about it more later on. The brown parts now we have our stomach, pylorix, and descending duodenum. Now, how do we recognize these from each other? First of all, we know that the stomach is a left-sided organ, so we should expect to see it on the left side of our cross-section. Also, we see all this large folding in there, and those are called rugae folds. They're kind of like these internal folding membranes of the stomach that allow the stomach to expand when it gets fuller and fuller. Just a little bit extending towards the right, more medially, we will first run into the pylorus, or rather the pyloric antrum followed by pyloric canal followed by pyloric sphincter, or just the pylorus, which is the actual valve. Now, recognizing what this is in terms of what part of the pylorus is a little more abstract, but the way I recognize it was it should be more towards the left than the duodenum, because we know it goes, as the stomach feeds out through the pyloric valve, you're going to get duodenum more to the right. And we know our descending duodenum is a right-sided organ. And that's why I know this is the descending duodenum. Another key point to notice about the duodenum is it appears to have a much thicker appearance. You see an itty-bitty lumen within a much rounder shape. I kind of picture the duodenum almost like the equivalent of a artery. It's very thick around the lumen, whereas the colon, if we go to a more caudal view, the colon has a much rounder, or not rounder, but like more kind of squiggly, compressed lumen with a much wider space. So I think of the duodenum like an artery, and the colon more like the contours of a vein, which we saw were more compressed and much wider with thinner walls. So I think that exhausts the majority of this one. Again, pylorus should be more to the left than the duodenum, and you can easily recognize the duodenum. So the pylorus or the pyloric part of the stomach, or the pyloric valve, should be somewhere around here. Looking more at this cross-section, this is a more caudal view. We went from thoracic vertebrae 12 to lumbar vertebrae 1. We're going to start seeing parts of our kidneys. We see the right kidney is much larger, and that is because the right kidney is a little more cranial than the left kidney. The left kidney we're only starting to touch here. We're about halfway through the right kidney. We still have our aorta, and now notice in the more cranial view, our caudal vena cava was still a bit to the right, because we know it enters through the right crus of the diaphragm. However, as we move more caudally, it's going to become medial. All right, so we have our aorta, our caudal vena cava, and as far as muscles go, again, we still have our apaxial muscles, but now we've moved further down the abdomen. We're not on the ribs anymore, so we're not going to see any latissimus dorsi, and we're not going to see any intercostal muscles. Now what we're going to see are our external abdominal obliques, our internal abdominal obliques, and our transversus abdominis, and of course still our rectus abdominis. And so now we have not liver anymore. This is now our spleen. We go a little more caudal. We know on the left side we have the spleen, and we'll see it kind of wrap around from lateral to medial view along the ventral aspect of the body wall. We will still see parts of the liver at this level, but I chose to omit them because they're far less noticeable than the giant spleen that makes up half our dog, it seems. All right, and then once again we have colon. Now, how do we know if it's ascending or descending colon? Well, we know ascending colon should be on the right side. We know descending colon should be on the left side. So near the spleen, I expect to see descending colon. On the right side, where there might not be any organs just yet, we expect to see ascending colon. And as I said before, we have our descending duodenum, and you can recognize that because, again, it appears to have that thicker wall. And that's really just the lumen that projects throughout of the small intestine. That is part and parcel to the absorption of the small intestine. And of course, all our crazy little macaronis going on in the center of the gut, those are going to be our jejunum, the middle part of our small intestine. And you'll see most of them getting transected or sagittally cut because they run all over the place. Is there anything else I need to point out about this? I think that's really the bulk of it, really. So yeah, cool.